Question says, calculate the magnitude and direction of the Coulomb force on each of the three charges shown in the figure below. So what you can see is that this charge is going to exert a repulsive force on this charge, and this charge is going to exert an attractive force on this charge. And so each of these charges are going to act on each other, and so it wants to find the force exerted on each of these charges. And so we're going to name the charges. So Q1 is going to be the 6 microcoulomb force. Q2 is going to be the 1.5 microcoulomb force, and Q3 is going to be the 2 microcoulomb force. Now there's two ways to go about this. So the first way is that we could, for example, we could take the reference force, so we'll say the 6 microcoulomb force. We could say, let's add up the total forces by these two, and so the total force, total force on Q1 would equal K times, it would actually equal Q1 times K times Q2 over 0.03 meters squared plus Q3 over 0.05 meters squared. So all I'm doing here is saying that the force of Q1 is equal to Q1 times E, the electric force, or the electric potential from charge 2 plus the electrical potential from charge 1. I don't particularly like that method because it'll actually take you more time. So the old-fashioned method of just saying, using Newton's third law, that each force exerts an opposite force. So we can say that there's on force 1, so there's a force of 1 on 2. So, or we can say that there's a force of 2 on 1, and there's a force of 3 on 1, and then there's also this other force of 3 on 2. We can figure out what each of these are, and if we wanted to know, so this is the force of 2 on 1 and the force of 3 on 1, and then we have this force of 3 on 2. So if we wanted to know, for example, if we knew what the force of 2 on 1 was, if we wanted to know what the force of 1 on 2 was, it's equal and opposite. So we just have to calculate three forces and then arrange them in adding and subtracting to the way we like. So let's go ahead and figure out what each of the forces are. So let's say the force of 2 on 1, the force of 3 on 1, and the force of 3 on 2. So the force of 2 on 1, so 1.5, so it'd be the force is equal to K Q1 Q2 over R squared. And so we have 8.99 times 10 to the negative 9th, or times 10 to the positive 9th, I'm sorry, times Q1 is going to be 6 times 10 to the negative 6th coulombs, and then we're going to multiply that by 1.5 times 10 to the negative 10th, so 1.5 times 10 to the negative 6th coulombs, and we'll divide all of that by 0.03 meters squared. Then you'll repeat that for each of the individual charges. So you would replace Q1 or Q2 with Q3, and then R squared would become 0.05 instead of 0.03. And then the last thing you would do is you would replace Q1 with Q2 and Q3, and this would become 0.02 squared. So the numbers you should get is this would be 89.9 newtons. This should be 43.152 newtons, and this should be 67.425 newtons. So now we just got to do our free body diagram. So the force on charge 1, so here's charge 1, and we have this repulsive force of F21, and then we have this attractive force of F31, and so all you have to do is take F21, 89.9, and subtract F31, 43.152. So the total force of on Q1 is equal to 46.748 newtons, and you can determine whether or not it's to the right or left, because if we have F21 minus F31, if that's a positive number, then it's going to be going in the direction of F21. So it would be moving to the left. Then for the force on charge 2, so we'll just call this force of Q2, force on Q2, it's going to be equal to, so we'll just draw charge Q2. So here's this, and we have a repulsive force from Q1. So we'll call this F of 1, 2, and then we have an attractive force from Q2, so we'll call this F of 3, 2. And so then we come up here and we say, well, what is F of 1, 2? F of 1, 2 is equal and opposite of F of 2, 1. So we have 89.9 plus 67.425. And so the total force on charge 2 should be 157.325. And that would be in newtons. Then the last thing we have are charge 3. Oh, that didn't work, so charge 3. And so we're going to have an attractive force to the left and another attractive force to the left. So here's charge 3, and it has F of 2 on 3, and then it has F of 1 on 3. And so actually my arrows should be the other way around. My larger arrow should be on the larger force. So F of 1 on 3 is equal to F of 3 on 1, and F of 2 on 3 is, or F of 2 on 3 is equal to F of 3 on 2. So we just add those numbers together, 43.152 plus 67.425, and you should get that the force on charge 3 is equal to 110.577, and that's to the left.